welcome everyone to today's webinar. There's still a lot of people to join, but they'll pop in as we move along, Zara. Today we're learning about what makes a building material healthy with Zara D'Cotta from Healthy Homes. This is the first of 3 presentations that's happening in the next month. Is it? We're doing them all within a month?
2 initially.
2. So we'll put up the link in the chat as well for the next webinar so that you can all register for that. Just a few housekeeping things. If you can just keep yourself on mute. We've got time at the end today for Q&A. So if you save your questions for Q&A, I know that some people do like to use the chat bar for questions. So if you want to do that. And if Zara can answer them as we go along, she will. If not, we'll address them all at the end. That's about it for me. I'll hand you over to Zara.
Thank you so much, Tamara. I really appreciate that. And before I kick off today, I just do want to do an acknowledgement of country. I'd like to acknowledge the traditional custodians of the land throughout Australia, from where you're all dialing in from today, and their elders past and present. And I want to acknowledge their connection to the land, sea and community, and in particular those of Bundjalung country, where I am presenting from today. I recognise and respect their cultural heritage, beliefs and their relationship with the land, which continue to be important to our First Nations people still living today. Well, first of all, thank you so much for joining me for today's lean-in session, in which I'm going to be talking about what makes a building material healthy. And I have to say that this opportunity to present to you today means so much to me, and it honestly feels quite surreal, because I was just saying to Tamara, there was a time in my life where I was navigating a significant set of challenges, which I'll touch on in a moment, and I couldn't see a way out. And if someone had have said to me then that I would one day have an opportunity to chat to architects about what I'd learned as a result of these experiences, I probably I wouldn't have believed that might be possible. So you being here today means a lot to me, not only on a professional level, but also a personal level. So it's amazing to see so much focus on sustainability of building materials. It's so important. But there is a whole other range of factors that need to be considered in order to determine how certain materials might impact the health and well-being of the people that live in the home. And that's what I'm going to be talking on today. And I also want to start by acknowledging how much respect I have for you, and the work that you do is something I've really come to appreciate over the last couple of years. And yeah, the significance of the role that you play in your clients' lives is just, it's so important. So yeah, hats off for giving up this time out of your busy working day. So to give you a bit of background on me and how I came to be doing the work that I'm doing and to being here today, I guess you could say there's been a long series of realizations and lessons, and I'll probably be learning these lessons for the rest of my life. But started with my first breast cancer diagnosis nearly 10 years ago, and another cancer diagnosis 2 years later. And within that 2-year period, as I was navigating my own challenges, I also sadly lost a really close lifelong friend to breast cancer. And that led me to asking a lot of questions, discovering the role that our diet, our environment, our lifestyle can play in supporting our health and well-being. And after my first cancer diagnosis, I went to a wellness retreat. I switched to organic food, switched to organic cleaning and personal care products, learned to meditate. Was pretty sure that I'd learned all the lessons that I needed to learn off the back of those experiences. But after that, cancer had never made me sick. I hadn't had to go through chemo, but I had about 20 plus symptoms that no doctor was able to diagnose or pinpoint. And I was fortunate to find an environmentally aware health practitioner, and we established the link that I am one of the 1 in 4 people that is genetically susceptible to mould, and my cancer treatments and surgeries and all the stress that I'd been through had put me on the extreme end of the scale in terms of environmental sensitivities. So I spent the following 4 years, after having a building biologist assess my house. I was told that would be something I would need to do for the rest of my life, any time I wanted to move houses, to make sure the home would be okay for me to live in. I then left Melbourne, moved to Sydney, and spent 4 subsequent years moving from one water damaged building to the next, trying to find a home that would enable me to heal. And I remember a very distinct moment when I first moved into the home I'm in now in northern New South Wales that led me sorry, to deciding to study building materials and building biology. I had decided that moving into a newly built home was going to be the key to overcoming mold illness and getting my health back on track. And in many ways it has been. But I woke up after my first night here and my eyes were stinging so severely that I had to get out of the house after I let, open the windows and doors to let fresh air in and let the building ventilate. The build had been finished 3 weeks prior. And I presume it was because of chemicals off-gassing from building materials and paints and carpets. And I had a rash for the first few months and bouts of nausea. And I remember thinking through my experiences with mold illness and then through this that, I'm an adult and I understand now the link between my environment and my health, but what happens to young children who might be experiencing health issues as a result of their environment and their parents don't have this awareness? And it was then that I realized the huge scale of change that's required to, the building materials we use in our homes and the way homes are built. And I decided I needed to learn all I could about building materials so that I could one day build my own dream healthy home and do whatever I can to advocate for change in the meantime. So I began my studies here in Australia, studying with building materials and home design and how to assess building materials using building biology principles. And then I knew that this was an area that I really wanted to focus on and specialize in. I didn't want to do assessments in homes because of my environmental sensitivities. And I really wanted to be part of the longer term solution so that fewer people are getting sick because of their homes in the first place. So I then went to study at the Building Biology Institute in the USA, where there is a specialist certification pathway for building biology students wanting to specialize in new builds. And my intention initially was to empower residential clients embarking on renovations and builds to make informed decisions about the health impacts of building materials and home design. But quite quickly, I had architects and builders reaching out wanting to do a residential course that I created. And I had a lovely architect go through that first course and tell me this was really important information that actually everyone in the building industry needed to know. And something I realized as I spent hundreds upon hundreds of hours researching the known health and environmental impacts of different materials was one of the biggest barriers to change, because architects and builders, building designers are so busy in the running of your businesses and projects that who's got all that time to do all the research? So I created a mastermind group for building industry professionals, and there's another lovely architect that went through that and said to me, you need to reach out to the Australian Institute of Architects. So it is because of some wonderful architects that I've come to being here today. I'd love you to just say hello in the chat box. It feels, I love that I get this opportunity to present to you from my home to wherever you are, but it feels very one way. So just say hello in the Q&A box and let me know where you're dialing in from. So in terms of what I'm going to cover today, I'm going to talk you through what building biology is, and then I'm going to talk through the 9 criteria that I use to assess the health and environmental impacts of building materials. And then I'm going to share some additional considerations that I use to determine mold susceptibility, and then I'll go into the pros and cons of 3 commonly used materials, and also why context is important when making building material choices. Hello, Eve, Carmen, Annika, it's great to see your names in the chat box. Thank you. And something I want to say in terms of the criteria that I'm going to be talking through, I've learned 2 systems which are somewhat similar but also different in Australia and the US. So the system I'm using today is a variation of the 2 based on my knowledge and understanding of both systems and what makes the most sense to me. So has anyone heard of building biology? Have you worked with a building biologist? Maybe you've had your home assessed. I'd love you to let me know. So building biology literally means Building for Life, and it was founded in Germany in the 1970s. So after World War II came the need to build a lot of homes really quickly, and there was a group of professionals that noticed a link between significant decline in the health of the population as they moved to synthetic building materials and faster, untested methods of construction. And they founded building biology in the 1970s. And in terms of what it is the study of the relationship between the built environment and the health of the human and our surrounding environment. And you want each of these, the goal is for each of these three things to be in harmony. And I often say that human health feels a bit like the forgotten cousin in new home builds amidst all this focus on sustainability and energy efficiency. And it's so brilliant. The changes coming into effect in the NCC this year in relation to condensation management. I was so blown away when I saw the scale of the changes, because when I was first made aware of my own sensitivities to mould 8 years ago, I was very much cast in the loony bin. My doctors didn't believe me. My family and friends did not believe that mould could be making me sick. So the fact that this is being recognised and such changes being made to our building code is amazing. But what we also need to consider in terms of meeting the requirements in relation to condensation management is that, we don't become so, if you become so laser focused on energy efficiency, but don't consider other potential health or environmental impacts, or becoming so laser focused on mold susceptibility materials that you don't consider other health impacts. And this is something I've learned through my own experience in choosing to move into a home that I thought was going to, purely based on how likely I thought it might be to have mold, and not considering the health impacts of VOCs in newly built homes. But I really hope that there comes a day where, it doesn't become a challenge to find a home to move into that is not water damaged and not going to be off-gassing high levels of VOCs. So I'm sure you're already well across the changes to the NCC, but just to make sure we're all on the same page in relation to the ones that are relevant for what I'm talking about today. The first one, the requirement in relation to condensation management, the performance requirement, is that risks associated with water vapour and condensation must be managed to minimise their impact on the health of occupants. And the Australian Buildings Codes Board acknowledges that these are minimum requirements only that address walls and roof spaces, and that designers and builders all have a role to play, as well as the occupants of the building, to manage condensation. And then in the design checklist provided in the Condensation in Buildings Handbook, one of the items it references is the need to in conveying the intent of the moisture control strategy for designers to have advice covering strategies and materials intended to prevent condensation and mould. So how do you assess a material for its mould susceptibility and other health and environmental impacts? So the first thing that I assess is probably the most straightforward is the material naturally occurring? So nature is very much considered the gold standard in building biology, ideally using materials that are natural and unadulterated, and that have that don't have any unpleasant or toxic odours. The second one is the ecological impact of the materials, and this considers everything from the whole life cycle of the material from cradle to cradle. So we want to be aiming to use to avoid depleting the earth of irreplaceable natural resources, or resources that are being harvested in an unsustainable manner, and also consider how much energy is required to grow the material, extract it from the ground, process it, distribute it to site, and also are pesticides required to grow it? If it is a renewable resource, how long does it take to grow? So timber wouldn't get as high a rating as a material like bamboo, because bamboo only takes a few months. Timber takes 10 years to grow. And then you want to consider what happens at the end of its useful life. So can it be recycled, or is it biodegradable? if it goes into landfill, is it going to leach toxic chemicals into the environment? And then energy consumption, which is pretty straightforward. And then the thermal properties of the material, so looking at the surface temperature, its insulating and heat storage capacities, and using the materials to make the most of opportunities for free heating. And this is what I'm going to share with you on the next slide. Is there are so many, it is really hard to make perfectly healthy material choices, and this the next slide will illustrate why. So foam is often used because it is a really good insulator, but the irony of that is that it emits such a high amount of greenhouse gas emissions. So, and then not only that, for every kilo of expandable polystyrene, there are 174 litres of water consumption, 500 grams of chemical waste, 2.1 grams of plastic waste, and 5 grams of paper waste. In addition to that, styrene is a group 2A probable carcinogen to humans, and there is evidence that it is carcinogenic to animals. It gets transported in the air, the water, it contaminates soils, and it also it disintegrates into microplastics and nanoplastics and causes harm to marine life. It makes its way into our water, our food system, and our drinking water. And the reason I'm sharing this material is because there's obviously changes to requirements in cooler climate zones to have subfloor insulation. And this is really the only widely available cost-effective way to insulate underneath a slab. But I really hope that, we can't turn a blind eye to the impact that this material is having on the environment and wildlife. And I hope that this can lead to some really constructive conversations about the need for innovation to come up with an alternative that is going to be easy to be adopted on a widespread scale. And this is an image of a piece of polystyrene found in the Arctic, which will ultimately disintegrate and make its way into the ocean and wildlife. So the fifth consideration is off-gassing. And I have to say, I can remember, I've got 2 distinct memories of walking into homes that were newly renovated or close to being finished. And my first impression was not how the home looked, it was the lack of toxic odors. And that just goes to show how accustomed we are to being overwhelmed with the smell of a new home when we walk in. So again, the goal is to use natural and unadulterated materials, and also avoid using materials that may have elevated radioactivity levels. In terms of the sorts of ingredients, toxic ingredients that can off-gas from building materials, volatile organic compounds. I know there's a lot of awareness about these, like benzene, xylene, formaldehyde. There's also another subclass of VOCs called semi-volatile organic compounds, and they're more difficult to measure, they're heavier, they take longer to release because they have a higher boiling point, and they persist in the environment for longer. And the other one is radon gas. So anything that is sourced from the earth, depending on where it is sourced from, may have radon gas, may emit radon gas. It's not as much of a problem in Australia as it is in countries like the US, but it is an important consideration because radon gas is the second leading cause of lung cancer globally, and it's the leading cause of cancer in non-smokers. So granite is an example of a material that can have high levels of radon gas. So this is the other thing to bear in mind, is that just because a material is natural does not necessarily mean that it is healthy. And in terms of what I just mentioned in relation to VOCs, is that low VOC and zero VOC labels can be really misleading because it doesn't require the manufacturer to declare semi-VOCs. So triclosan is also referred to as microban and biofresh, and it's a known hormone disruptor that interferes with thyroid metabolism. It may affect immune function, cardiovascular function, and result in reproductive and developmental defects in children. And it can also come with an increased risk of allergies and asthma and eczema. And the bizarre thing about this is not only that a paint that is labelled VOC can contain such ingredients, but they can also be, they can carry logos that imply that they are a suitable product for people with sensitivities and respiratory problems. And just because a building is green doesn't necessarily mean that it is healthy. And the CSIRO carried out a study that found the highest level of toxic VOCs like formaldehyde in a green building. And formaldehyde is a known group 1 carcinogen to humans. And there are other countries that are a lot more onto this than we are here in Australia. So at the end of 2019, there were paediatricians at a children's hospital that realised that 70% of children in the oncology ward at the time had come from homes that were recently renovated, and they suspected it was because of high levels of formaldehyde in building products. So trying to make sense of ingredients labels and trying to come to conclusions on a product, I'll admit, can be really difficult because the information that we need to assess a material more often than not isn't listed on safety data sheets. So declare red list free labels. They are 100% of the ingredients in those products have been disclosed. The Living Building Challenge red list approved products, that's a second tier. So one or more ingredients have, there might be exceptions with one or more ingredients due to a lack of healthier alternatives. And then declared is that products are 100% disclosed, but one or more are not covered by an exception. And so the declare red list in 2019 had about 800 products, and they say that they update that list every year. So I'm sure it's substantially more. But the other thing to consider is there's more than 80,000 chemicals in commercial use today. Many of them are untested. So that's just something else to bear in mind. Pharos, which is PHAROS, is another database that has thousands of chemicals and their known health and environmental impacts. I actually have a little bit of a chuckle to myself every time now I read this word, hygroscopicity, because it's been a few builders that have joined the mastermind and come to the calls and told me very proudly that they're now using this word on building sites with their teams. So hygroscopicity is the ability of a material to absorb moisture from the air when humidity levels are high and release it when humidity is low. So it will help regulate humidity in the home, and timber is an example of a material that has an incredible ability to regulate moisture levels. The next consideration is diffusion and absorption properties. So vapor permeability is another, is also referred to as diffusion properties. And this is the ability of water vapor to be able to pass through a material. So in building biology, our homes are considered our third skin. And just as we need to be able to sweat through our skin, we need water vapor to be able to pass through the walls without contributing condensation in the wall cavity. So vapor permeable materials are key to achieving that. And then absorption properties is materials that will remove pollutants from the air. So timber, again, has an amazing ability to do that. So it will actually absorb VOCs from the air. And materials with these properties also provide really good, they will absorb sound and provide good acoustics. The next consideration is one that blows a lot of people's minds, and I am going to be talking more about this in my next presentation on what is a healthy home. So this consideration is the material electrically conductive? So metal is an example of a material that conducts electricity, and it can act as an antenna for stray electrical currents and carry electricity around the home and potentially exacerbate electromagnetic fields inside the home. And sorry, I should have said earlier, on each of these slides I've listed, there are 25 guiding principles of building biology. And so I've listed the principles that relate to the set of criteria that I'm talking about. And at the end of this presentation, I've got a downloadable PDF with the 25 principles. So there will be a link in the chat box that you'll be able to use to get that sent to you if you would like to. And the ninth consideration is the health impacts of the material. So giving an overall rating for the health impacts based on that set of criteria. So that's the 9 criteria in a nutshell, in case you want to take a screenshot. So let's look at 3 commonly used materials and the advantages and disadvantages and how I've rated them against these criteria. So timber framing. So the advantages of timber are that it's naturally occurring, it's a renewable resource, it is vapor permeable, hygroscopic, it will absorb pollutants from the air, and it can hold up to 16% moisture before it's susceptible to mold growth. And I find it fascinating that a typical wood stud can take on and give off approximately 236 mils of water before being at risk of mold growth. And this is, you may think, well, I'm not in a humid climate, this is an important consideration, but human beings contribute to elevated moisture levels in the home by breathing, sweating, showering, cooking. So that water needs to be able to move from the inside to the outside without contributing to condensation, and having framing that can help take on some of that moisture definitely is an advantage. It's also got good thermal properties and it's not electrically conductive. The disadvantages of timber are that it is susceptible to termites, rotting, and condensation. It can be contaminated with fungus when it's delivered to site. If it's treated, it will emit toxic chemicals like copper chrome arsenate, and moisture levels above 16% will likely result in mould. It's also being harvested at an unsustainable rate. So steel framing. I found this such an interesting material to assess, and my views on it definitely differ depending on the context in which it's being used. So the advantages are that it is durable, it is long life and low maintenance, it has a high strength to weight ratio, it repels water, it's resistant to rot and termites, it's non-combustible, it's recyclable. It sounds pretty amazing when you consider just the advantages, and then you look at the disadvantages. So it is highly thermally conductive. It heats up and gets cold really quickly, and this is a known contributor to thermal bridging and condensation and mould in new buildings. It is a finite resource. It does conduct electricity. It has a high embodied energy, but you can argue that this is potentially offset by its long lifespan. It has no hygric buffer capacity. It's not vapor permeable, it's susceptible to rust. And the other thing is that metal can give false high moisture readings in moisture meters. So if moisture does become a problem in the home, and the homeowner just wants to get an indication of, whether there is a leak behind a wall, and they've got a moisture meter to be able to get a feel for it themselves without having to go and get their home assessed, it is going to be more difficult for them to tell if there's metal framing giving false high moisture readings. And this gives you an idea of how much moisture a steel framed building with plasterboard can hold, so 5 gallons or 19 litres, versus timber frame with timber sheathing, 189 litres. I find that quite mind-blowing. And then a masonry wall is 1,892 litres. It's quite astounding. PVC, this is a big bugbear that I have. So it is very good in terms of its thermal properties, and it's not going to impact the electroclimate. Disadvantages are that it is really toxic and hazardous at every stage of its life cycle, and it is difficult to recycle. It off gases when it's heated, when temperatures are high. It can leach into household water and into soil, and there is many more known health effects than I can list in this one slide, but it's a known hormone disruptor. It's linked to testicular and breast cancer, polycystic ovarian syndrome, diabetes, heart disease. And then vinyl chloride is a group 1 carcinogen, and it can leach dioxin, which is widely recognised in scientific literature as the most potent carcinogen known to man. And then there's the social impacts of the materials to consider. So 10% of the world's PVC is produced in China using forced labour. And in the PVC producing region of China, the 7 plants there every year emit around 49 million tonnes of carbon emissions and 9.3 tonnes of mercury into the air. And last year, the US introduced sanctions to stop PVC produced there from being imported into the US. And there was a bill in the Senate in Australia, but this seems to there hasn't been any further action by Australia on this issue. And then you might have seen recently the train that derailed in the US, leaching vinyl chloride into the environment with quite harmful impacts for the people living in the surrounding areas and wildlife and the environment. So this is how I've rated each of these materials against the 9 criteria. So for each material, I've given them a rating between 0 and 3, with 0 being pretty terrible material that we should avoid using if we can, and 3 being the highest possible rating. And I have given them, I've then averaged out I've given each of the materials an average based on the 9 criteria. So untreated timber is an almost perfect score of 2.8. The only reason I've given it a 2 for ecological impact is because of the amount of time it takes to grow and the rate at which it's being harvested. And you can see that PVC gets the lowest score. And even though steel is 0.77, the context in which a material is being used is such an important consideration. For instance, I think it makes a brilliant material used in the right context as a roof material. So it's not to say don't use a material, but I find that I have residential clients that they want to make the right decisions, and it can be really hard when you factor in material availability and costs. So if their ideal healthy choice isn't going to be possible, having a rating scale really helps them make the next best choice that might fit within their budget. And I love this quote by Michael Smith, who's a natural builder, and he says that natural building is necessarily regional and idiosyncratic. There are no right answers, no universally appropriate materials, and no standard designs. Everything depends on local ecology, geology, and climate, on the character of the particular building site, and on the needs and personalities of the builders and users. So yeah, looking at the climate, not only the climate, but the microclimate of the home, the factors unique to the site, looking at nearby health hazards that might need to be taken into consideration. And this is something that I'm going to touch on in my next presentation. What is a healthy home? And then again, where is the material being used? So it would not make sense to have a timber rooftop, but metal could make sense. And then here are some additional considerations that I like to factor in to determine the mold susceptibility of a material. The first one is, will it attract dust? Because dust is a food source for mold. So if it's a material with a textured surface, and dust is likely to be attracted to that and be difficult to clean, it can be more susceptible to mold. So that leads into my next consideration is it easy to clean? Is it easy to wipe dust off the material? What is the drying potential of a material if it gets wet? So, plasterboard is it is vapor permeable, but it's not, it's lower down the scale in terms of hygroscopicity. And if it gets wet, it needs to be pulled out and replaced because it becomes moldy very quickly. And then how processed is the material? So the more processed a material is, the more likely, the better a food source it is for mold. So I hope that gives you an understanding of the sorts of things to consider when looking at materials based not only on mold susceptibility, but other health impacts as well. And I think a really important message to get across, I'm always reinforcing to my clients, is it really is about balance and not perfection. There are so many grey areas. There's so rarely a black or white, perfectly healthy choice. So it really is about balancing the individual needs, values, circumstances of the client, and to try and create a home with no chemicals in it it's almost impossible. And unless you've got a client that's got really extreme environmental sensitivities, you need to accept that there are likely going to be chemicals that come into the home. But if you think of, the body like a bucket, there's only so much that we can handle. So doing the best that you can to reduce the amount of chemicals that clients are being exposed to is going to make a massive difference. And also knowing, just by asking questions of suppliers, if they're not declaring information on safety data sheets, asking them questions about what else might be in product other than semi-VOCs. So often I reach out to them and I so often get told, we've never been asked this question before. And don't underestimate the importance of the role that you can play in driving change just by asking more questions and sending a message to product manufacturers that we want them to be more transparent and we want them to stop greenwashing and improve their formulations even more. So if you are wanting to learn more about the world of healthy homes and building biology, I'd love you to join me for the next lean-in session, which is happening 2 weeks from today at exactly the same time at 12 p.m. Daylight Savings Time here in Australia. And I'm going to talk about the 5 pillars of the healthy home. I'll talk about some of the building biology principles that I haven't talked about today. And I think Josh is going to put Joel, in the chat box, the link to the page where you can get the building biology principles sent to you. If you want to read them between now and the next session, I would highly recommend that. And then if you're wanting to explore building materials on a deeper level than I have been able to cover in 45 minutes today, I've definitely done my best to cover as much ground as I could. There are 2 ways that I can help you with that. So the first is the Healthy Building Materials Mastermind, which I run a couple of times a year. And that is a 10-week online learning experience. And in that, what I've done is I've condensed my many hours of research into an hour and a half of content each week. We have fortnightly live calls, so we catch up and we discuss learnings. I learn so much from the people on these calls as well. And the relationships that have been formed in these groups, you see a picture there of some of the people that have been through it. I've had 2 events last year for Healthy Building Materials Mastermind alumni because it just so happens that people that care about health and our environment are pretty amazing people that want to support each other's efforts to drive the movement for change. So in that, I also give the ratings for how I've assessed each of the interior and exterior materials. And you get to hear the perspectives of environmental health, natural building, building science experts that I've interviewed, which I know has been really helpful for participants to help them arrive at their own conclusions on different products. So the next intake for that starts at the end of May, and I do have a maximum of 8 spots for each group, just because of the quality of the conversations, the relationships is really important, and the support that I'm able to provide. And the link that is in the chat box that Joel has posted also contains, if you want me to send the details of you when they're announced, you can enter your details there. And the other one is something that I'm doing as a one-off, which is the Healthy Building Materials Mini Mind, focusing on roofs and walls. So that starts next week. It's a 5-week program, which I've created purely for people that just want to get their head around the materials that you need to know about when NCC 2022 comes into effect on May 1. And at the moment, I've got 3 spots left for that. So again, you can get the details sent to you via the link in the chat box. And if you're called to reach out after today, I would be so delighted to hear from you. If we were in person, I'd love to be able to stand around and have a chat to you afterwards and hear more about you and your work. So this is where you can find me online. If you message me on LinkedIn or Instagram, I'll come back with a voice note. And there's a lot of information that I post on my Instagram feed. That's probably where I hang out the most. So thank you so much. And if you've got any questions, I'd love to get to them in the chat box. Sorry, the Q&A box. Sorry, I'm just trying to navigate to, I'm going to stop sharing. Q&A. Oh, I can't hear you, Tamara.
That's because I was muted. There's one so we record, Carol, we record all the events and then we post them on our YouTube, and then they'll also go out in the EDM as well. So if you can't be present at them, there's always an opportunity to catch up.
Thank you.
There is a question here from Lucas in the question and answer. He says, having worked on DHHS, I'm aware that a large amount of the older commission housing stock have serious mould issues. Is there much that can be done for older buildings? And how much does the building account for in mould growth compared to occupants' living practices, i.e. heating, cooling, venting and venting the dwelling?
That's a really good question. So the first part of it, it really depends on the extent of the mould, but I've noticed a consistent trend in clients that I support that are going through renovations. I always get them to get a mould assessment first, and in every situation, the extent of the mould problems has been more extensive than they first realised, and it becomes a matter of choosing whether they renovate or whether they'd actually be better off knocking the building down and starting again. And often it's cheaper for them, because if they have to go through it, they've got to pay for the remediation, they've got to pay for the materials to be remediated, and then they don't know until the materials are being removed. You know, they might find further problems and they could have a cost blowout. So, and that from an environmental point of view is a huge consideration. But I've had clients with homes that are less than 10 years old that have had to undergo significant renovations to mould because of mould. So it's not just old homes. And then, sorry, the second part of the question was, I can't actually see it here, sorry. Sorry, can you read the second part of it? Oh, here it is. How much does the building account for mould growth compared to the occupants' living practices? Oh, to put a percentage on it, I'm not sure, but both are really important. And that's why, having the strategies in place in terms of materials and design have a huge role to play, but then making sure the client's educated so that their home stays the way it's intended is really important as well.
Another question here, just a bit lower. It might.
Yeah. Any materials you could offer up in terms of PVC? So it depends on the context. So for pipes, this is difficult because I know in terms of viable options. So polyethylene and polypropylene are less toxic plastics than PVC, but I know that they're, in terms of availability, in terms of sizing for residential use, is challenging, but that could be an option to push suppliers for. And PVC windows, there's obviously other options like aluminium and timber, aluminium timber composite. But yeah, it depends on the context, but I hope that that's helpful. No one has talked about electromagnetic impacts. I see you're addressing this. I just quietly addressed this. I love that you're onto this, Catherine. So many variable impacts. It is about addressing the worst or highest impact. Yeah, it is a huge topic, which I will touch on in the next session. And it's not to say that we need to do away with technology or our electric appliances, but there's so much that we can do to reduce our everyday exposure levels by being aware, particularly, and it's something that you can really influence a lot and make a difference to in the design stage. Passive house is the answer to control condensation and mould. I agree, it does go a long way to addressing condensation and mould related issues. But something I would say is there's other factors. Again, I'm going to touch on these in other sessions, but factors unique to the site, protecting exterior materials from moisture. Yeah, really important considerations as well. Any other
No, but Dana from Newcastle said that she's familiar with Nicole. Oh, hang on, the chat just disappeared on me. Nicole, I don't know how to pronounce that. Beej-Slam's work. Healthy Material Labs courses and low tax life courses. Will be interesting to see how specific to Australian materials your course is. And thank you for the presentation.
Yes.
Lots of thank yous and looking forward to the next session as well. So.
Thank you so much. Yeah, so my course is all Australian materials. So yeah, I started with the Healthy Building Materials course at ACES, and I've then subsequently done heaps and heaps of additional research on Australian-based building products. And thank you, John. Hi, Paul. Passive house is not relevant to the tropics. So I won't weigh in on that. All right, well, thank you.
Asked one more question. Which is better, galvanized steel downpipes or PVC? I think maybe you answered that one.
Yeah, I would say so.
And then Misha from Sydney said, originally from Germany. I have quite a few friends in Germany who live in very healthy homes, have impeccable eating habits, and often also keeping the house very clean and tidy. Turns out their kids are now severely allergic, have intolerances to all sorts of foods, and struggle a lot, likely because their bodies never learn to fend for themselves.
Interesting.
Another question, anonymous. Would you recommend that a mechanical consultant be engaged to assist with exhaust and services designed for residential projects to help with airflows and exhausting?
Yeah, because if you do have air filtration, ventilation systems, it's really important to make sure that they are properly balanced and properly installed and maintained.
All right, well, I think that's it for today. Thank you so much, Zara. That was great.
Thank you so much, everyone, for joining.
Thanks, everyone, for joining. Joel has put, I think Joel's put the link for the second webinar in the chat bar. If not, you can find it on our events page on the website. Oh, yep, there's the next session link there if you wanted to use that one now. Well, thank you, Zara. We look forward to seeing you again on the 28th.
Thank you so much. My pleasure.
Bye, everyone.